So we can't talk about exponential models without talking about compound interest, because compound interest is a prime example of something where the rate of change increases as the value of an account increases. So the basic sort of interest that we work with in basic math classes is called simple interest, where we only charge interest on the amount that we borrow or lend or whatever. Compound interest is what you get when you charge interest on the interest. So here's how that works. Suppose we borrow $1,000 at 10% interest, and the interest rate is always quoted for a whole year whenever we're talking about interest. So if we borrow $1,000 at 10% interest, well, we might think, okay, at the start of the year, I owe $1,000. But then over the course of the first year, don't I accumulate interest? I accumulate $1,000 times the interest rate is 10%, which is 0.1, times, we're looking at 1 year. Over the course of the first year, I build up $100 in interest. So at the end of the first year, I don't owe $1,000. I owe $1,100. Oh, but then if it's the Renaissance and you've got these fancy new decimal numbers sitting around, it might occur to you to think, well, I don't think I want to just charge interest on that 1,000 original dollars in the second year. At the start of the second year, you owe $1,100. Why not charge interest on the whole $1,100? So in the second year, we accumulate not $100 in interest, but $110 in interest. If I'm the lender, I like that a lot. I just got 10 extra dollars for free for doing a little bit of arithmetic. Right at the end of the second year, we owe $1,210. So in the third year, we go in owing $1,210. Over the course of that year, the interest we accumulate is 10% of that, so $121. At the end of the third year, we owe $1,331, which is $31 more than we would have owed if we were just doing simple interest, which we like if we're the lender, we don't like it if we're the borrower. So what happened? Each year we took what we started with and added 10% of that. So each year we multiplied by 1 plus the interest rate, or 1.1. We started with 1,000, right? When we first took out the loan and no time had passed, we owed $1,000. So the amount we owe after t years is 1,000 times 1 plus the interest rate to the t. And I'm writing that as 1 plus the interest rate instead of just doing the addition on purpose, and it's because we're going to see a pattern here. Okay, so it's the Renaissance. We've just gotten our hands on these fancy new decimal numbers. And we start thinking, why wait to the end of the year to add on that interest? Why not compound more often? Why not add on the interest every half a year? So every 6 months. Then still a $1,000 loan, 10% interest. At the start, we owe $1,000. But now over the first half of a year, the interest we accrue is 1,000 times the interest rate times not 1, but a half. Over the first half of a year, we accrue $50 in interest. So after the first half a year, we owe $1,050. Now we might think, oh, well, I don't like this. This is actually worse, right? In the last example, after the first time we compounded, we owed $1,100. But now this has only been 6 months. It hasn't been a whole year. Going into the second 6 months, the second half of a year, we owe $1,050. So during that second half of a year, the amount of interest is $1,050 times 0.1 times a half, and we get $5,250 in interest. So at the end of the first year, instead of having accumulated $1,100 owed, we've accumulated $1,100 plus $250, which, I mean, that's great. We only had to do a little bit of extra arithmetic. Going into the first half of the second year, we owe $1,102.50. So the interest we accumulate is $1,102.50 times 10% times a half. And I'm going to round this to 2 decimal places since we're talking about money. In the first half of the second year, the interest we accumulate is $55.13, which means at the end of the first half of the second year, we owe $1,157.63. Okay, $1,157.63 times 10% interest times a half is $57.88. Adding that to the $1,157.63, we get that at the end of the second year, we owe $1,215.51. Okay, this is not as big a gain as the original compound interest was, right? With simple interest, we would owe $1,200 at the end of the second year. Compounding once a year, we owe $1,210 at the end of the second year. Compounding twice a year, we owe $1,215. So the original compound interest got us $10. This one only got us an extra $5 beyond that. But still, it's more. We would like to be able to do this, especially if we can find a convenient way to calculate it. If it's the Renaissance, we really can't find a convenient way to calculate it, but we can find relatively inconvenient ways to calculate it that's worth $5.50 to us. These days, the calculator will help us calculate this really easily, because we can write this as an exponential function again. Each time we compounded, we only multiplied by 1 plus the interest rate times a half, so 0.1 over 2. But we did it not twice, but 4 times. So this gives us another exponential model. Again, we start with 1,000. This time we multiply by 1 plus the interest rate over 2, but we do it twice as often. So in t years, we multiply 2t times. So when we compounded once a year, we had 1 plus the interest rate to the t. Twice a year, we have 1 plus half the interest rate to the 2t. We can expand this to compounding as many times a year as we'd like. n times per year if we want to. And usually we describe that using words like monthly, quarterly, that's 4 times a year. Every 6 months, that's twice a year. Semi-annually, that's also twice a year. So we describe in words how often we're compounding. The interest rate is always an annual interest rate. So the amount of interest we would pay if it just sat there for a whole year. Our P0 is the amount that we invest or borrow or deposit, whatever it is that's generating this interest. And then we compound it n times per year for t years. So in figuring our multiplier, we take the interest rate and split it up. The interest rate is only covering part of the year. So we take r divided by n. But then we do that n times per year. So we take n times t. The most common mistake in using this formula is forgetting where the n goes. If you remember where the n came from, what it represents, then you will not forget where the n goes. Because the reason that we take r divided by n is that we're splitting up the interest. And the reason we take t times n is that we're compounding over and over and over again.